So in my demo video, we showed that when we dropped a ping pong ball and we were able to measure the velocity versus time of it falling, that we got a line with constant slope. And if you look closely at the video, we were able to do a line fit, and it said that the slope was minus 9.8. Now, I didn't explain it in the video, so I need to explain a little bit about that now. So the first thing that you will have to take on my word is that it doesn't matter what we drop. And this is what's interesting about what Galileo said. It doesn't matter what we drop, but everything will fall with an acceleration in the absence of all other forces and only under the Earth's gravitation will fall with an acceleration of 9.8, but 9.8 what? 9.8 meters per second squared. So acceleration due to the Earth's gravity is 9.8 meters per second squared. Now, you might say, what happened to the minus sign? Well, the minus sign only came because the software that we were using had defined up as the positive y direction, and it was using y, up as the positive y direction, and this was the velocity in the y direction. Since up was the positive y direction, and the object was speeding up in the downwards direction, it was speeding up in the minus y direction, that means the direction of the acceleration was indeed minus. So a lot of you will say, if you learned physics in high school, what are you talking about? We learned that acceleration due to gravity was always minus 9.8 meters per second squared. If you learned that, that was absolutely incorrect. That was absolutely incorrect because remember, acceleration is a vector. And the direction is determined, or the sign is determined by the direction. The magnitude of the acceleration is 9.8 meters per second squared. The direction is what direction? What is the direction of the acceleration due to gravity near the Earth's surface? It is downward. Down meaning towards the Earth's surface. You need to know that's what we mean by down. It's downward. So if I define the direction as downward, then the acceleration due to gravity is equal, if I define the positive direction as downward, then the acceleration due to gravity is plus 9.8 meters per second squared in the positive direction. Let's say I define that as the positive x direction, right? In the positive x direction. Let me add here that in the x direction is denoted as x with a little hat on top. We're going to come when we talk about vectors and talk about that, but what that means, I'll just say here, it means in the x direction. That's just notation to mean in the x direction. Or if I said down was plus y, then we would say the gravitational acceleration is equal to plus 9.8 meters per second squared in the y direction. That's y with a little hat on. The official word for that is caret, y caret, but it's y with a hat. But if I define up as the positive y direction, then my acceleration due to gravity is equal to plus 9.8 meters per second squared. And you might say, wait, you just made a mistake. No. In the minus y direction, because my acceleration of an object falling is in the minus y direction, right? It's plus 9.8 meters per second squared in the minus y direction. And we can distribute that minus sign over here. So we say, oh, okay, in that case, acceleration due to gravity is minus 9.8 meters per second squared. But what we really mean is minus 9.8 meters per second squared in the y direction. The minus sign belongs with the direction, not with the number. So if you learned in high school that the gravitational acceleration was minus 9.8 meters per second squared without a doubt, then you also learned that was when you always defined upward as a positive direction, which is absolutely not necessary. You can define any direction you want as a positive direction. So what you need to know is that the acceleration due to gravity is 9.8 meters per second squared in the downward direction. And we generally call that, because it's a special number that comes up all the time, instead of calling it a sub grav, we define that as little g. Little g. And so this is it. Little g is 9.8 meters per second squared in the down direction. Whatever down is, whether it's plus y, minus y, etc. Plus x minus x. The other thing is where did the units come from? How did I know those units? Well, it was because in that video analysis, I actually used the units of meters and seconds. So when I got an acceleration, it came out to be meters per second squared. You've also learned this maybe as 32 feet per second squared, etc. But in MKS units, that's it.